picking up with example 3. Okay, and this is where the special right triangles come into play. And here they're telling you, okay, you got yourself a special right triangle. This is where, you know, the legs are, it's an isosceles right triangle, which tells you right off the bat you're dealing with a 45 degree triangle. And they said, okay, well, and this is the square root of 2. Okay, well, you kind of know this, right? All right, so, do they label they label the triangle here? They're not really labeling it. Okay, so let's say we're looking at this 45 degree angle. Okay, I want to do the sine of 45 degrees. Okay, of that 45 degree. I know what it is now, so instead of putting in A, B, or C, I'm putting it actually in. Okay, all right. So what is the sine? Opposite SOHCAHTOA, right? So sine of 45, this 45 degree angle is equal to the opposite side, which is equal to what? 1. Over the hypotenuse, which is equal to what? Square root of 2. Okay? All right, what's the cosine of 45 degrees? And yeah, normally we would rationalize and all this, but we're gonna actually stick it in our calculator here in a second, okay? So what's my cosine at 45 degrees? 1. Adjacent side, right? Over square root of 2. Oh, look at it, it's the same thing, right? Sine and cosine are the same thing. What's my tangent of 45 degrees? 1 over 1, right? Which is 1 over 1, which is 1. All right. Okay, I want you to tell me what 1 divided by the square root of 2 is.
Seven.
0.7071, right? So 0.7071, and that's 1. All right, now I want you to first go to your calculator, and I want you to hit the mode button on the top. I want to make sure you're in the right mode, because there's 2 ways to measure angles. One's degrees and one's radians, and I want to make sure you're in degree mode. So if you're on mode, goes 3 below. You see radian, degree. Make sure degree is the thing that's highlighted on your calculator.
Does this look right?
Yes. Okay, you're in radian now. You need to be over here to degree. Okay, pressing enter. Okay, you want the degree to be black. Okay. Degree mode. Okay, did you press enter? Degrees. Okay, good. All right, now do second quit out of mode to get to that. I want you to type in sine 45 degrees. So sine button, 45 degrees, and tell me what you get.
Same thing.
0.7071.
How do
You just put in 45. You do sine and then you put 40.
0.7071.
Yep, that's it. Now put cosine 45 degrees. Oh, look, 0.7071. That's that ratio, okay, of adjacent over hypotenuse. How about tangent of 45 degrees?
1.
You better get 1. Yes, you get 1. Okay, and this is true no matter what size triangle you're dealing with. Okay, because these ratios, right, in a 45 degree triangle are going to exist no matter what. So therefore, these ratios are standard for these degrees. And the reality is, any set of degrees, as long as everything adds up to the degrees in a triangle, will always be the same. So the sine of a 30 degree angle will always be the same. The sine of a 27 degree angle will always be the same.
So
Okay.
it doesn't matter if it was like 3 square roots of 2, it'll always be 0.7071.
That's right. So think about that. Because for this to be 3 square roots of 2 means that these sides are equal to 3, right? And once you put them in the calculator, right, it's going to be the same ratio. Okay, and so that's very useful, and we'll see why as you proceed. All right, so let's go look at example 4. It says, okay, so now we're looking at another special right triangle. We're looking at the 30, 60, 90. Okay, and they're really kind of drumming the idea home that these ratios exist no matter what size your triangle. So that here we are. we got this situation, 30 degrees. Okay, and this one obviously is 60 degrees, right? How do I know that that's 60 degrees?
Because it has to be.
Yeah, because that's got to add up to 180, right? All right, so let's start by taking the sine, the cosine, and the tangent of that 30-degree angle. So sine of 30 degrees equals what? Nellie?
1 over hypotenuse.
2. All right. Cosine of 30 degrees, Abby, equals what?
1.
Okay, so the cosine is adjacent, so ka,
Oh.
so adjacent over hypotenuse.
So the square root of 3 over 2.
Mm-hmm. And the tangent, Esther, is equal to, of 30 degrees is equal to what?
1 over 3 square root.
1 over the square root of 3, total, right? All right, I want you to get your calculator out, and well, first crunch, well, 1/2 is the same thing as 0.5, okay? What's square root of 3 divided by 2? Make sure you get out of the, outside the radical when you divide by 2. What did you guys get?
8660
Point.
or point. Yeah.
0.8660. Did everybody get that? Did you get that, Esther?
No.
Okay, so make sure when you're doing the square root of 3, you hit this right arrow and get out from underneath the radical. So you're not taking the square root of 1.5, you're taking the square root of 3 divided by 2. So do square root of 3. Okay, do a little right arrow right here. Yeah. Let me see. Second square root of 3. Close that parenthesis.
Okay.
Okay, and then hit divided by 2. And they're giving it to you in scientific notation, which is really 0.866. Did you get that, Abby? Yeah, you got it in scientific.
0.866.
Yeah, you got scientific notation. Yeah, but it's 0.866, 0. Okay, and then this one right here. These are probably all should be 1 divided by the square root of 3 is
0.5774.
0.5774. All right, now I want you to go into your calculator and hit sine 30 degrees. What is it? 0.5. How about that? Okay, cosine 30 degrees. Oh, that lines up at 0.866 right here. And then tangent 30 degrees. 0.5774. Okay, so I can have I can multiply this, any factor that I want to, and these ratios will stay and put. Okay, because they'll always be the same.
So
All right.
satisfying to get the same thing twice.
Yeah. It is, and that's they're trying to make this connection that these are ratios, but these ratios are associated with triangles that have these angles. Okay, because there's only one way to draw a triangle that has these angles. Okay, the only way you can do it is to have these ratios. Okay, and the point is, yes, you've learned special triangles, 45, 45, 90, and 30, 60, 90. But these ratios exist with any, configuration of angles. As long as everything adds up to 180, those ratios will be the same. Okay. All right. So here we go. This is the other thing that's kind of cool about this. Okay, look at example 5 because they're talking about your calculator, and of course I've been doing this anyway with your calculator to begin with. It says use your calculator to approximate the sine, cosine, and tangent of a 74-degree angle. So sample keystroke. Okay, just ignore that. Just tell me what the sine of 74 is. Just put sine 74. Stick it in your calculator. What'd you get?
0.96.
Mm-hmm. All right. What's the cosine of 74? Should be 0.27, right?
Mm-hmm.
Did you get 7.2 or 2.7?
2.7.
Okay. All right, and then tangent of 74. Okay. All right, good. All right, now This thing's called the Pythagorean trigonometric or Pythagorean identity. It's a trigonometric identity, and let's see why. This is what the next thing is. It says if you look back at examples 1 through 5, you notice that the sine or the cosine of an acute angle is always less than 1. The reason is that these trigonometric ratios involve the ratio of a leg of a right triangle to the hypotenuse. The hypotenuse is longest side, right? So that if you always do that, you're always going to have something that's less than 1, okay? Because it's always going to be a proper fraction, right? Then it says the length of the right triangle, the length of a leg of a right triangle is always less than the length of a hypotenuse. So the ratio of these lengths is always less than 1. Because the tangent of an acute angle involves the ratio of one leg to another, the tangent can be less than 1 or equal to 1 or greater than 1. The tangent can be anything, right? All right, now it says a trigonometric identity is an equation involving trigonometric ratios that is true for all acute angles. You're asked to prove the following identities. The exercise is 4752. All right, so this is the first one. It says sine squared A plus cosine squared A actually always equals 1. And when we say this is squared, we're not squaring the angle, we're squaring the ratio of the angle. Okay, so like if I were saying sine squared of 30 degrees, I'd really be squaring the 1/2. It'd be like 1/2 times 1/2, okay? That's what I'm saying there. That is always true, and this is the other thing that's true. The tangent of an angle A is always equal to sine of the angle over cosine of the angle. Okay, and you can, if I do SOHCAHTOA in here, and I do fraction arithmetic, you will see why that's true. And you can, let's just prove this to ourselves. How about this right here? Sine squared 30 degrees plus cosine squared 30 degrees. Does that equal 1? Okay. Okay, I want you to take sine 30 degrees squared and then hit plus, get out of there, and then hit cosine 30 degrees. And actually you type it in as you type it in like this, sine 30 degrees, and then they say squared, and it's not the 30 that's getting squared, it's this that's getting squared. Okay, do that. So sine 30, and then hit the little square symbol, plus cosine 30, and then hit the little square, and you get, did you get 1? Okay.
I got 0.05.
Okay, yeah, because your parentheses are all messed up. Okay, you got to do sine 30, close. Because then what you're doing is you're squaring the 30. So you're doing sine of 900 degrees. Okay, you want to actually, so you're doing this sine of 30, and then you're squaring. It's a ratio, sine of 30, and then the square's outside, plus cosine 30, and then close the parenthesis, hit squared, you should get 1. Okay, now let's do sine of 37 degrees squared. Sine 37 degrees squared plus, oops, sine 37 degrees squared plus cosine 37 degrees squared equals 1. All right, how about this one? So tangent of 30 degrees, they say equals the sine of 30 degrees over the cosine of 30 degrees. Okay, so first I want you to do sine of 30 divided by cosine of 30. Sine 30 degrees divided by cosine 30 degrees. Get that number in there, and then I want you to do tangent 30 degrees. And it should be the same thing. All right, why is that? Well, what's tangent is equal to opposite over adjacent, right? And what's sine? And we said that's going to equal sine over cosine. Well, what's cosine? What's sine? Opposite over hypotenuse divided by adjacent over hypotenuse. So that means that's the same thing as saying this, right? Opposite over hypotenuse divided by adjacent over hypotenuse, which is the same as saying opposite over hypotenuse times the reciprocal. That ends up being opposite over adjacent. Okay, so it all comes out in the wash, right? Okay, now this is last couple of examples, which is where this all really becomes useful. All right, so this is you're trying to measure this tree. Okay, you're measuring the height of a Sitka spruce tree in Alaska. You stand 45 feet from the base of the tree. You measure the angle of elevation. This is how people measure things. This is how people survey land and measure distances on land and stuff like that. This is how we measure distances in space in stars and stuff like that using this method. You measure the point from the point on the ground to the top of the tree. So you see those surveying tools. What they're doing is they're doing angles. Okay. To the top of the tree, so you can write a trigonometric ratio that involves the height h and the known length on the ground, which is that 45. Okay, so let's take a look at this. Let me just draw this. So cover up the solution on this, and let's see if we can reason through this. Okay, we got to remember SOHCAHTOA. Okay, here's our tree. All right, and we want to know how tall it is. We know that we're here at 45 feet away from the tree. And we know that this angle, because he's using a special surveying tool, is 59 degrees. Okay? All right, now, so tell me what trigonometric ratio do I need relative to this 59-degree angle if I want to measure what side is h relative to this 59-degree angle? Is it opposite or adjacent?
Opposite.
It's opposite. And what side is this?
Adjacent.
So which of these uses opposite? Which of these SOHCAHTOA uses opposite and adjacent? Tangent. So we're going to use tangent. We're going to say tangent of 59 degrees equals the opposite. But this is what we're trying to figure out, right? H equals h over, we know this one, 45. Now all we got to do is algebra and solve for h. Okay, so what should I do? I need to multiply both sides by 45. So h is going to equal 45 times the tangent of 59 degrees. So you put that in your calculator and tell me what you get. Tangent 45, which is 59. I'm sorry, tangent. Did I say 49? Yeah, 59. It's the length of the ground. Okay, tangent 59 times 45. So what is that? 74.89. I'm gonna they'd probably just say 0.9 here in the book. Yeah, 74.9 feet. All right, so you see how useful that is. There's no having to get into a cherry picker, right? Stand there with a big tape measure and measure something, okay? You can stand on the ground. You just have to measure. You have to have one measurement on the ground, which is easy, and then your angle thing.
I wonder how they figure out the angle.
They have like, it's like I don't know, what's it called? I'll have to find the actual tool. I'm thinking sextant, but I may be wrong. But it's something that does this, and it will tell you the angle. And you kind of look at it.
Kind of line it up.
You line it up with the top and the bottom, and it will tell you the angle. And then you're just going to use this ratio here to figure this out. All right, so let's look at the last example. Example 7. Okay, now the situation is a little slightly different, but there's still going to be a trigonometric ratio involved. It says that the escalator at the Wilshire, Vermont Metro Rail Station in Los Angeles rises 76 feet. So 76 feet here at a 30-degree angle. So here's my 30-degree angle. Of course, this is my 90-degree angle. All right, and I want to know this distance. Now, what side is D right now of that right triangle? What side is it? It's the hypotenuse. Okay, so what am I given right now? Relative to this 30-degree angle, what is this side to this 30? It's the opposite. So which trigonometric ratio uses opposite and hypotenuse? Sine. So how I'm going to set this up? I'm going to say sine of my 30-degree angle equals opposite, 76, over hypotenuse, D. Okay, so I'm going to have to measure, I'm going to have to multiply d on both sides. Okay, to get rid of here. And then I got to divide both. So now I've got d times sine of 30 degrees equals 76. Now I've got to divide both sides by sine of 30. Remember, sine of 30 is just a ratio. It's just a thing. It's going to be a number. Okay, so this goes out. So now d will equal 76 divided by the sine of 30 degrees. So what is that? 76 divided by sine of 30 degrees. 152 feet. Did you guys get that? Okay. So the algebra is a little bit different in terms of how you're solving for stuff, but the steps are roughly the same. Okay. You're isolating the variable, and if the variable starts off here in the denominator, the easiest thing to do actually would probably be, you would say sine of 30 degrees equals 76 over d. Put this over 1, and you can cross multiply, right? 76 equals d sine 30, and then divide. So, all right. How do we do?